which is by Dr. Chetan. He is the CEO and Chief Scientist of Visio Ingeni. Can we have a grand applause for him, ladies and gentlemen?
Hi. Good evening, everybody. Thank you for your patience. Last session, I think so. My name is Chetan. I'm from Visio Ingeni. I'm one of the co-founders of the company. We are predominantly an AI-based computer vision company based on security surveillance domain. We began as a security surveillance company, and over a period of time, we have gone into different domains. We have a broad spectrum of solutions, and we started as just a core machine vision company, but then we have actually gone into AI. We have started doing different frameworks, etc. So I would like to just touch upon what exactly the company stands for, as well as our domains. Self-learning systems, we are trying a robotic OS, visual robotic OS, just like a Linux OS. We are trying to make our own robotic OS. That's why the self-learning system is in place. We believe in being different. Why we say that is because we are very customer-centric. From the day one, from the inception, we've always looked into the real-world problems, and we kick-started the company with real projects without R&D, but we learned as we proceeded, and this has given us a lot of edge in what we have learned so far, especially in the vision domain. Coming to our key domain and solutions, we have been building our own AI library, predominantly pattern recognition, face recognition, or object recognition. And it's purely based on C++ and Python. It's got both variants, and it's agnostic to the platform. We are able to put the whole application on an embedded system, server, Windows, Linux, everything. It's kind of matured since 2017. We have applied it in the defense sector. Must say, before we get into it, I must say about our clientele. Since 2012, based in UK, headquartered in UK, we have spread across the world. We have been in Las Vegas for banking sector. We have a Middle East branch. We have a Southeast Asia branch as well, mainly dealing with different type of customers. We also have verticals now where banking, multi-biometrics for banking. We have defense and security sector where it's been from the day one. We are also into medical imaging. Two of our solutions in medical imaging is diabetic retinopathy based on AI. We use TensorFlow architecture for that. We also have a specific field, something that is still yet to be released by us, is Visiotropics, which is our SPV actually, based in UK. It's based on orthotropics, the lip separation of any person sitting in any working environment. It's got an ergonomic effect on the health. So we have done a lot of study based on basic algorithms since 2013. Since 2014-15, we have been applying MLP on it. We have got great results. Now we are applying TensorFlow and Caffe kind of architectures. So what happens there is it's going to alert parents, especially children, using the laptops or iPads. The lip separation gives sleep apnea. That's what we have understood from the data. We have done a lot of clinical trials in London School of Facial Orthotropics. Those are medical imaging solutions. Like I said, robot sensory operating system. We have combined several sensory perceptions, sound to vision, mainly vision actually. So what we have done is that operating system, quite recently we have started working in the kitchen application for kitchen robotics. So Deep Cooking is something that we acquired as a company in UK. It is a Scottish company, and we are able to actually do some kind of cooking applications like creating a pasta salad or anything based on vision. So it can identify a tomato from a small tomato or a big tomato. That's the level of accuracy in object recognition. Coming to multimodal biometrics, we are not just looking at face as biometrics. We are not just looking at iris or common biometric variants, but we are also looking at behavior, gait. We have got a lot of data trained on gait, pattern of walking, and we have got a lot of data trained on emotion and behavior combined together. The reason for that is while we are working in the security surveillance space, we have got hold of a lot of data of how the crowd behaves, how people behave in a mob or a small structure, small cluster. So we have trained our AI based on that, so that's actually helping us out. We also have driverless and drones. We have a company called PNLI under our group in UK, which is actually trying out dashboard cameras to find occlusions and signs in the street as well as animal and pedestrian detection, etc. We are attempting to do FCNN, I mean fully convolution neural network for that, because we have different aspects, so we are trying to build that based on that. That's also based on TensorFlow. Space imaging, we are actually trying to find anomalies, objects, something like a space net. We are creating our own model. We've got a lot of success in analyzing 2.5 GB, kind of a data frame, and it's quite accurate. It's about 700 milliseconds. So it's in the R&D stage, and we are trying to look for the future aspects of it. Just a quick snapshot of our product portfolio. It's quite broad. 70% of them are now using deep learning technologies. Predominantly the crowd management suite that you have in the blue there. We have different statistics coming out of those modules. We have direction and bearing, not just the direction of people walking with respect to the frame, but with respect to the camera held in the frame. So with respect to GIS mapping, we are able to get bearing as well. We are also able to find fire, something very unique about it. Fire has not a definitive pattern, so it cannot be based on pattern recognition. Something very different that we are doing for fire recognition, fire detection is we are using frequency domain features. We are combining frequency domain features like we are using fasted Fourier transform in the West to compute very quickly on the fly, and we are able to append our model based on the features of the fire. So we are able to identify a headlight or a flashlight from a fire in the same vicinity. So which is very difficult problem. We are able to do that. ONGC in India, we are trying out a pilot there. Several Middle East companies, oil and gas companies, we have worked there on that. Something else is we also have object recognition system. Something unique about it is we are attempting the world's fastest object recognition system or a solution. 1000 frames per second is what we are attempting. We have two variants of it. One is pre-trained model based, which is quite fast, which can be accelerated with a normal CPU. But of course, with the help of Intel, we are actually now trying to use edge devices to do that as well. Coming to the second variant of object recognition is on-the-fly recognition. We have a unique solution. It's a part of my research, academic research, previously 8 years ago, which actually auto-computes different variants of an object being clicked by the user. It's actually able to train a light model, which is about 10 kilobytes or less, and we're able to learn as we go. So in the number of frames, the beauty of video analytics is that we have frames coming and we can keep appending our model. So we are doing that as well parallelly. So those are the unique things. Several products are now actually getting into predictive applications rather than just inference applications. That's where we stand. Coming to what we are actually trying to solve recently, since last year, because until 2017 we have been in the defense sector, so we were very much in a covert operation, confidential products and proprietary products. Since 2017 we are trying to do 3D face recognition, which is very similar to what iPhone X has got, but what we have done is we have done data augmentation. So we have a data augmentation tool which is based on MLP. The biggest problem that we will have is different demography of faces. So for instance, African face versus the Eastern Asian faces, that's a completely different variant. So we are able to train our model based on depth data as well as the real data based on fusion of that. And we have got 2 or 3 different variants of that as well. We can use a time of flight sensor, Sony semiconductor time of flight sensor or PMD time of flight sensor for such data. We also are well acquainted with structured lighting as well. So those are the things, as well as fire detection, as I quickly mentioned, we are able to optimize it to an extent of 98.7 accuracy. Face recognition, we are at 1.75 over 1 million FAR, which is quite a good number compared to iPhone X data. We also have a good FRR, less than 2% in face recognition. Since a few months now, we have been trying out all these frameworks in Intel devices like edge device. Quite recently we started doing fire detection implementation for edge devices like Movidius. The reason for that is of course fire should be detected in like oil refinery. We cannot have everything connected. Everything should be kind of connected to the edge devices. Something more unique, I just want to stop it at that point, is we have something called